Day to all. Today we are going to say about Gilbert's and Wester method. See, this is the problem we have seen before in that largest candidate tool also. Here the small electrical appliance is produced on a single model line. The work a content assembly product has been reduced to work elements listed table below along with the other informations. The line is to be balanced for an annual demand of 1 lakh units per year. This is a very important thing. The annual demand they have given, as well as that line operator they have given 50 weeks per year and 5 shifts per week, 7.5 hours per shift. And manning level will be a 1 worker per station. Previous experience suggests that the uptime efficiency for the line will be 96%, and the repositioning time loss per cycle will be 0.08 minutes. So the given thing is they have given that annual demand 10,000. They are given annual demand of 100,000 units per year, which is 1 lakh per year, as well as they have given operator weeks 50 weeks per year, 5 shifts per week, and 7.5 hours per shift. The efficiency they have given uptime efficiency is 96% and the lot cycle 0.08. They asked to determine the total work content time and the required cycling time RP and so. So we will see this problem in that Gilbert's-Western method. See, this is the given table. The procedure is same as before in the largest candidate tool. First we have to draw the precedence diagram. This precedence diagram according to the work element and that particular TEK minutes and the precedent by. What I said before, that we have to take first element as a without predecessors. See, this 1 and 2 work element doesn't have any predecessor. See in that given table column, this is the first work element and this is the second work element. These two doesn't have any predecessor, so we have to take these two as a first. Then according to that predecessor, you will draw this predecessor diagram. See, this 3 work element have a predecessor of 1. In that previous table you will see this work element number 3 have a predecessor of 1. See, likewise consider about the work element 4. This 4 is having a predecessor of 1 and 2, and 5 have a predecessor of 2, and 6, this work element number 6 have a predecessor of 3. And now we look at work element 4 in that procedure diagram. See, work element 4, which means the predecessor means it should be finished after that particular work element. The 4 have a predecessor of 1 and 2. If the 1 and 2 work element will finish, then only the work element number 4 will start. Likewise, what all the predecessor we have? Already told you that 5 work element have predecessor of 2 and 8 have 4. Here this 7 have a 3 and this 8 have a 3 and 4. We'll see this 8 for 3 and 4 predecessor. We'll look out in the table. See, work element 8 have a 3 and 4. Likewise, we will do that predecessor diagram. Then after that predecessor diagram, In that Gilbert-Wesser method, we will take as a descending order. But here, in that large standard rule, we will take as a descending order. But here in that Gilbert and Western method, we will go for another method. The thing is mainly we have to draw this diagram. After that, we will put the TEK minutes along with that work element. See, the one work element have a TEK minutes of 0.2 and two have a 0.4. Likewise, we will put all together in a responding work element that we have in that tabular column. This is the TEK minutes with that particular work element. Okay. The next step for that Gilbert-Wesser method, what the table column will make it as a column wise. See, this is the first column. We'll consider as a this is the first column, and this is the second column. This is the third column. This is the fourth and the fifth. We will make this procedure diagram as a column wise. Then we will take this column according to that particular TEK minutes that I will tell. See, in that first column, we will look up that which one has a highest TEK minutes. As I said before, this is the first column. In that first column, work element 1 has a 0.2 minutes and work element 2 has a 0.4 minutes. So here the 0.4 is the highest value. So we have to take this as a first one, work element 2 with the TK minutes of 0.4. We have to take this as a first one in that particular table. Likewise, we have to take all tables. See, in that first column, 0.4 minutes as a first, and the remaining one work element as a 0.2. Likewise, for column 3. From column 3, what are all the work elements are coming? 3, 5, and 4. We'll go for the producer diagram behind. See, these 3, 4, and 5. This is the third column. If you look at here, which one is the highest one? 0.7 and 0.3 and 0.1. Likewise, we will make it a table column for all the columns. So I took as a 0.7 as a biggest one is a first one of that second column, and the second one is 0.3. Likewise, we will make all columns. Then we will make a station as we have seen in the previous largest candidate rule model. Likewise, we have to take which one as a first. There is if there is a no predecessor, we have to take as a first. So we will consider from top to bottom. We will coming from top to bottom. We can take a first as a without predecessor. So here this is a without predecessor. So we took that work element number 2. Again we will come for top to bottom. There is again one we can consider. This is the without predecessor. So we will take a one work element. Then we will go look up which one already we have took this work element number 1. So this 3 we will strike out. So now we have finished this work element 2, 1, 3. Again what we will do, we will come from top to bottom. We have to see the predecessor, what all the predecessor which we have already took. Here We have took already 2, 1, 3. So we will come these two already we took. So for this 5, because in the 5 work element have a predecessor of 2, already we have took the 2. Likewise we have to take the main condition here is, see, already I said 2, 1, 3. We cannot take this 3. Why? Because already we know that in that largest candidate rule, the condition we have taken for it cannot be exceed with the TC time, right? The TC time is 1 minute. Already we have find out that TC time 1 minute. So it shouldn't be exceed with that TC time. If we are taking this 2 and 1, there is no problem, because we have multiply with that. Sorry, we have add this zero point 0.6. It will come like 0.6, 0.4 plus 0.2 is 0.6. If we are again coming from top to bottom, we can take this one, because already we have took that 1. But see that TK minutes, it's a 0.7 minutes. So if we are adding that 0.4 and 0.2 and 0.7 means it will exceed. See what will be the result for this 1.3. So we cannot take this work element number 3, because it will exceed. So we have to check what are the things we have to. We can take this work element point 3. Yeah, we can take, because it cannot exceed with that TEC time, that 1 minute. So we can take this work element number 5. So we already took this work element 2, 1. We cannot take this 3. Now we can take 5, because the TK minutes 0.3. So zero point 0.2, zero point 0.4 and 0.3. It will come 0.9. Again we will come from top to bottom. What are things we can take? Because now its station time is 0.9 only. We can take 0.1 minute also, because it shouldn't exceed 1.0 minutes, right? So we can take any other things. Yeah, we can take this 4 also, because this TK minutes will have zero point 0.1 minutes. So it will come exactly 1 minute. So in that station 1, we have work element of 2, comma 1, comma 5, comma 4. These are all the stations come in the station 1. Likewise, we will do for remaining stations also. How we can take, what are all the predecessor we have already finished. Likewise, we will take that station 2, station 3, station 4 also. This is the Gilbridge-Webster method. Then another method is RPW, ranked positional method. This is the last method of that assembly balancing problem. The main difference is that we have to sum of the all the element. According to that sum of the element, we will arrange the table. Then the procedure will same as follow, is that previous method what we have done in that largest candidate rule, as well as in that Gilbridge and Western method will follow the same procedure. These are all the things in that assembly balancing lines problem. So thank you.